Welcome to the deep dive. Today we're heading back to the fascinating world of the late Cretaceous in Argentina.
That's right.
And our focus is on a really intriguing dinosaur, Bonapartenykus ultimus.
A very interesting one.
We've sifted through the scientific literature for you, the initial description from 2012, the latest findings from just this year, 2025, and some background on the rocks where it was found.
Uh,
Our mission really is to understand what makes Bonapartenykus significant, how it was found, got its name, where it fits in the family tree, and, well, the world it lived in.
Absolutely. It's kind of like detective work, isn't it? We're piecing together this picture from fossil fragments and the geology.
Right.
And Bonapartenykus is compelling because it gives us these crucial insights into the evolution of a pretty peculiar group of dinosaurs, the Alvarezsaurids, in a very specific time and place.
Okay, let's start with that name then, Bonapartenykus ultimus. It sounds like it carries some weight. What's the story?
It does, yeah. The first part, Bonapartenykus. Well, that's a direct tribute to Jose F. Bonaparte. He was a towering figure, really, in Argentinian paleontology.
Yeah.
Put the country on the map for dinosaur finds.
Ah, okay.
And Onychus just means claw, so literally Bonaparte's claw.
Bonaparte's claw. Nice.
And the ultimus part means latest. This refers to the fact that for Alvarezsauridae down in South America, this dinosaur shows up pretty late in the fossil record. We're talking Campanian maastrichtian, late Cretaceous.
A fitting tribute. So where exactly was this latest Bonaparte's claw dug up?
The initial find was, well, it was a major discovery. A partial skeleton, mostly articulated, meaning the bones were still roughly in position.
Oh, wow.
Though not totally complete, it came from the upper layers of the Allen Formation. That's in Rio Negro province, Argentina.
Okay.
And what makes it even more interesting is that this skeleton was found really close to some incomplete eggs and broken bits of eggshell.
Eggs.
Yeah, and these eggs turned out to be so distinctive they eventually got their own name, Areagadulithus.
Eggs found nearby. That really starts to paint a picture, doesn't it? Who first spotted how important this find was?
Well, the first mention was back in 2009 by Salgado and his colleagues. But at that point, they could only really say it was some kind of Alvarezsaurid, part of the general group.
Right, just broadly.
Exactly. It was the more detailed work in 2012 by Agnelin and his team, Powell, Novus, and Kundrad, that really nailed it down as Bonapartenykus, its own species.
Okay.
They designated the main specimen, the holotype, MPCA 1290, and that included things like a back vertebra, both shoulder blade and coracoid units fused together.
The shoulder socket area, basically.
Yeah, exactly. Plus the left tibia and femur, lower and upper leg bones, the left pubis still attached to part of the hip, another bit of the hip bone, and those two partial legs.
So maybe not the whole puzzle, but definitely enough pieces to get a good look at the animal.
Precisely. And they also identified two other sets of bones, MGP-IFD, GR166, and GR184, as also belonging to Bonapartenykus.
From the same individual.
They think so, yeah.
Yeah.
From the same individual.
Yeah.
These included like a shoulder blade fragment, a left coracoid, the bottom end of a right pubis, 4 neck vertebrae, and a single tail vertebra. So yeah, no complete skeleton, but a really informative collection.
And those eggs, they were unique enough for their own name, Areagadulithus, and even their own ooh family, Areagadulithidae. That sounds pretty significant.
It really is. The microstructure of the shells, their characteristics were just different enough. And the ooh family name, Areagadulithidae, actually honors the owner of the land where the fossils were found.
Oh, that's great.
Yeah, it's a nice example of how local cooperation is so vital in paleontology.
Absolutely. Now, you mentioned that 2025 research by Misso and colleagues. What new stuff did they bring to the table?
So their study looked at even more Alvarezsaurid fossils from the same geological formation, specifically from a place called Salitral Ojo de Agua.
Okay.
And they concluded these new bones were very, very similar to Bonapartenykus. They identified them as CF Bonapartenykus ultimus.
CF, what does that mean again?
Right, the CF is science shorthand for compare with. So it basically means the material looks a lot like Bonapartenykus. They're pretty sure it's closely related, but maybe not 100% certain it's the exact same species. Could be very close, maybe a slight difference.
Okay, got it. So we have a good handle on the discovery, the name. Now let's picture this creature. We know it was a big one for an Alvarezsaurid, right? How big are we talking?
It was, yeah. Definitely the largest Alvarezsaurid known so far. Current estimates put it somewhere between, say, 2.5 and 3.3 meters long. That's roughly 8 to almost 11 feet.
Wow.
And weight-wise, probably between 43 and 72 kilograms, so about 95 to 159 pounds. It's quite a bit bigger than many of its smaller, more bird-like relatives in the group.
That's a decent-sized dinosaur. What were some of the key features of the anatomy that helped Agnelin and his team know it was something new back in 2012?
They flagged several distinct characteristics in that main specimen. One involved these small ridges on the back vertebrae, the psychopophyseal laminae, which
Woof.
ended kind of abruptly above certain bony bumps. Another was the underside of the coracoid bone part of the shoulder, which was strongly bent inwards towards the middle, and it was covered in these delicate little grooves. Something similar is seen in Saxanicus. They
Interesting.
also noted the fused scapula and coracoid, like in Ceratonicus,
Yeah.
a really wide notch on the back edge of the scapula. And maybe the most striking thing, the ilium and pubis, the hip bones, were completely fused together.
Fused hip bones. You don't see that often.
No, that's unique among all known Alvarezsaurids. It really stands out.
Definitely an oddity for this group. Let's zoom in a bit. What can just one vertebra from its back tell us?
Oh, quite a lot, actually. Like other Alvarezsauroids, it didn't have pluricols, those air pockets.
Right.
But interestingly, the front surface of the main body of the vertebra, the centrum, was really deeply concave, cup-shaped, with a sharp edge. This suggests it might have been procarylous, meaning like a ball and socket joint with the vertebra in front. It could imply maybe more flexibility in the back compared to some relatives like Haplocaris or Patagonicus. The neural spine, the blade sticking up, was proportionally taller than in the more advanced Alvarezsauroids, more like the earlier branching ones. It also had deep pits, fossae, in front and behind this spine, like Bonapartenykus and Patagonicus. And then there's that unique feature we mentioned before, those laminae ending suddenly. Even the hole for the spinal cord was quite wide.
So much detail from just one bone. What about that fused shoulder unit, the scapulocoracoid? What did that show?
Well, the scapular part of the shoulder blade curved inwards towards the body's midline. It shares that with Alvarezsaurus, but most other Alvarezsauroids have a straighter blade.
Okay.
But like many others in the group, its front and back edges were almost parallel, and it had that distinct notch on the back edge. The acromion, where muscles attach, was sort of triangular, which you see broadly in Maniraptor dinosaurs, including birds. The glenoid fossa, the socket for the arm bone, faced backwards and outwards. And the coracoid part, the other bone in the shoulder girdle, had its lower half strongly bent inwards. That's a feature also seen in Paravis, the group, including birds, and their closest non-avian relatives.
It sounds like a real mix of older and newer features. Anything else about the coracoid?
Yeah, it didn't have a basipital tubercle, a little bump for a specific muscle. It was also quite thick along its front edge. The hole in it, the coracoidal foramen, was wide and rounded. Near the back edge, there were several ridges, probably for muscle attachments. The outer and upper surfaces were smooth, but the inner and lower edges were more sharply defined. It's a bit like Patagonicus, but in Bonapartenykus, that inward curve wasn't quite as strong, and the grooves were less developed than in Patagonicus, and definitely less distinct than a ridge you see in Ceratonicus.
Yeah.
And one other thing, the back inner part of the coracoid was quite thin and slightly curved upwards. The original author suggested this might be related to some kind of skin hardening there, maybe cornification, not like a full horny sheath, but something.
Fascinating. A potential clue about its skin. Okay, let's move towards the back end. How did its pelvis and leg bones compare?
Well, the shaft of the pubis, one of those pelvic bones, was more squashed side to side and narrower front to back compared to Patagonicus.
Okay.
Like the more advanced Alvarezsauroids, it didn't have a groove for connecting with the ischium, another pelvic bone. But unlike them, it did have a little ridge on the front edge of its lower end. And it had a rounded expansion at the bottom rear, the pubic boot, which some later relatives lack.
And that fusion.
Right, that strong fusion between the part of the ilium connecting to the pubis and the pubis itself, still the standout feature, unique to Bonapartenykus.
Yeah.
There's also a depression on the ilium, the Capitacus fossa, which was smaller, shallow, and long, with a low ridge above it.
And the actual leg bones. Anything special there?
The head of the femur, the thigh bone, was separated from the greater trochanter by a little cleft. Overall size and shape were pretty similar to Patagonicus. There was a noticeable rough bulge on the femur, probably another big muscle attachment point.
Powerful legs then?
Seems likely. The tibia, the main lower leg bone, was short, quite robust, and bowed outwards, laterally. There was a small bump near the top at the base of the conial crest, and the bottom end showed some signs of wear, maybe abrasion from how it moved or interacted with the ground.
We're getting a really detailed picture now. Okay, where does Bonapartenykus fit in the grand scheme of dinosaur evolution? It sounds like its family connections have been debated a bit.
That's right. It's been a bit of a puzzle. When Agnelin and colleagues first described it in 2012, Their analysis put Bonapartenykus inside the Alvarezsauridae family, specifically in a subgroup called Patagonicinae, as the closest relative, the sister taxon, to Patagonicus.
Okay, so initially sister to Patagonicus within the family.
Exactly. Then, interestingly, a study in 2022 by Alvarezsauridae and Lopatin also found it was closest to Patagonicus, but they suggested this pair actually fell outside the main Alvarezsauridae family.
Oh, so same close relationship, but maybe outside the bigger family group.
Precisely. Then adding another layer, a 2018 study by Zhu and colleagues, and some later analyses using their data suggested something different again.
Okay.
They proposed Bonapartenykus was actually a more basal Alvarezsauroid, meaning it branched off earlier in the evolutionary tree before both Patagonicus and another one called Achillosaurus. And according to them, it wasn't part of Alvarezsauridae as usually defined. So, yeah, competing ideas.
It's fascinating how the same bones can lead to different interpretations, these evolutionary debates.
Yeah.
What about the latest study, the 2025 one by Mezzo's team? Where'd they land on this?
Right, the 2025 study, the one that described those potential new Bonapartenykus fossils, their analysis actually swings back towards supporting the original idea from Aguilin and his team.
Oh, really? Back to the beginning.
Pretty much. Their analysis placed Bonapartenykus firmly within that Patagonicinae subfamily, inside the Alvarezsauridae family. Their evolutionary tree, their cladogram, shows Bonapartenykus as sister to that other specimen, NPCN PV 738, the one they called Cia Bonapartenykus, and then those two together are sister to Patagonicus, all neatly within Patagonicinae.
So the most recent data seems to reinforce that initial placement.
Seems that way for now, yes.
Yeah.
It really highlights how paleontology is always moving, New finds, new analyses, they keep refining our picture.
It really does. Okay, let's shift focus to the world Bonapartenykus lived in, the Late Cretaceous Allen Formation. What was that environment actually like?
The Allen Formation, well, it's mostly ancient river sandstones, dates back to the Campanian Maastrichtian stages, so very end of the Cretaceous.
Right.
What's interesting is the range of environments it seems to preserve. We see evidence for temporary lakes, ephemeral ones, areas with wind-blown sand dunes, aeolian systems, and river systems, fluvial ones, that were gradually transitioning towards the coast.
So near the sea.
Yeah, moving towards coastal marine environments like estuaries and tidal flats. It seems to have been a dynamic landscape where freshwater and saltwater influences met.
A constantly changing place then, from rivers to the coast edge.
Exactly. There was a study in 2015 by Armas and Sanchez that looked specifically at this. They described it as a kind of hybrid coastal system. You had tidal flats, but they were heavily influenced by storms in places, and these were linked up with those windy, dune-dominated areas.
Sounds like a diverse and probably challenging place to make a living. Who else was around? Who were Bonapartenykus's neighbors? The Allen Formation is famous for its fossils, right?
Oh, absolutely. It's yielded an incredible variety of dinosaurs and other animals. For dinosaurs, we know there were several types of titanosaur sauropods, those giant long necks.
Right.
Things like Bonatana, Manuka-Celsior, Panamericansaurus, Rhocosaurus, and even an unnamed Aeolosaurus species.
Wow, lots of giants.
Definitely. Then you have the hadrosaurids, the duck-billed dinosaurs, Bonapartesaurus, Kalumapasora, Apamposaurus, Willinacaque, quite a few of those too.
Plant eaters covered. What about others?
Yep. There was a notosaurid ankylosaur, Paticopelta, one of the armored guys. For predators, there were amosaurids, like Nibla and Quilmosaurus.
The dominant meat eaters of the time there.
Often, yeah. And also a large unenlarged Ostroraptor, which is related to raptors but much bigger. We even have early birds like Lamarcavis and Laminavis.
Birds do.
And flying reptiles, pterosaurs. A rodotin, a big Esdarchid, was found there. Plus other reptiles like Lamarchosaurus, which is related to the modern Tuatara, and even a plesiosaur, the marine reptile Coanectes.
A marine reptile, so definitely coastal influence.
Yeah, and though it wasn't on that specific list I just ran through, mosasaurs, those big marine lizards, have also been found in the Allen Formation, really cementing that connection to marine environments nearby.
Goodness, a real who's who of the Late Cretaceous. Bonapartenykus was living in a seriously crowded neighborhood.
It really was, part of a very diverse ecosystem, sharing its world with a huge array of other reptiles, on land and seemingly near the water too.
Well, this has been an incredibly informative deep dive into Bonapartenykus ultimus. Just to sort of wrap up, we've covered its naming honoring José Bonaparte, its discovery in Argentina as, well, the biggest known Alvarezsauroid.
Quite large for the group.
Its unique physical traits like that weird fused hip, the ongoing, scientific discussion about its exact spot on the family tree.
The phylogenetic puzzle.
Right, and the rich, varied environment of the Allen Formation where it lived right at the end of the Cretaceous.
Exactly. It's just a fantastic reminder of how much we can unpack from these fossil finds, not just about the creatures themselves, but about the ancient worlds they walked and the evolutionary pathways that shaped them.
So, thinking about that unique mix of features it had and that bustling ecosystem it was part of, it really makes you wonder, doesn't it? What was Bonapartenykus' specific job, its ecological role in that environment? How did it actually manage to coexist with all those other massive and varied animals? What pressures might have driven its evolution in that particular time and place? It certainly gives you a lot to chew on.
It absolutely does. It leaves us with that big question. How did this rather unique dinosaur fit into the incredibly complex web of life right before the end of the dinosaurs? A fascinating puzzle indeed.